Hello there, my name's Christopher Ray. I work for Southeastern Trains. I'm currently doing a 4-year apprenticeship. I'm in my first year. The first year is predominantly here at IPS College in Stroud. Throughout apprenticeship, we partake in different units for an NVQ. One of the units, the one that I'm currently doing at the moment, is mechanical maintenance, and you have different assessments that you have to complete throughout that unit. One of the assessment pieces is this. It's a valve. It's a pneumatic diaphragm valve. So it's powered by pneumatic air using a diaphragm. So a diaphragm, pretty much, this is a diaphragm. This gets bolted between the lower housing and the upper housing. The diaphragm air will then get pushed into the top, which will push on the diaphragm. The diaphragm gets pushed down. As the diaphragm gets pushed down, we have a diaphragm plate to give it a bit more stability, which pushes down because there's the spring that's inside. The spring is used for the air pushes down on the diaphragm, which will then push down the stem. And when the air is released, the spring then pushes the diaphragm back up. So if you can imagine that all being bolted down to a specific torque setting all the way around, which will then create a sill. As the diaphragm gets pushed down and the stem gets pushed down inside of the housing, the stem then comes down, which then the eye bolts onto the bottom of the stem. Through the eye, using a pin, the clevis is then held on. The clevis then gets pushed down. As that gets pushed down, inside here we have splines. So you've got your male splines inside here. Then on the actual valve itself, you've got the female splines. So the splines interlock, interlock with each other. And as you can see, as the stem gets pushed down, the clevis will get pushed down, which opens up the valve. And then as the air then gets released, the valve will then shut again. So if you can imagine, on this valve, you'll have 2 pipes bolted either side of here, and you'll have probably water or steam going through here. So as it opens, you can control the rate at which, say, water will flow. So if you only open it a little bit, then not so much water will flow, as opposed to when it's fully open and you'll have maximum flow. Because you've got the actual valve itself is controlled, this rod goes all the way through, which controls it. So in order to create a sill, inside here we have what's called gland packing. We've got the gland and the gland packing. So gland packing, an example of gland packing is this here. So the actual gland packing that's in here is about quarter of an inch. This is a lot thicker, so it wouldn't fit in here, but just for demonstration purposes, this would get, you work out how much you need to go around. You would then cut it off at a 45-degree angle. The reason you cut it off at a 45-degree angle is when you're putting it round, a 45-degree angle rather than a 90-degree angle helps to create a better sill. Throughout the centre here, you'd have probably 5 lots of gland packing all the way down. And what you want to do is, wherever your cuts are, you want to put one, say, at the top, then the next one you put it at 3 o'clock, and the next cut you put at 6 o'clock, 9 o'clock, all the way around. The reason for doing that is that you haven't got all the cuts all in one line, so it helps to create a better sill. Once, if you have to restrict the gland, we can use an extraction tool, which is basically like a pig's tail, sort of like a corkscrew. So you screw it into the gland packing itself, and then you pull it to take out the old gland packing to put new packing in. So this will then go on the side, like so, like that. When all this is bolted in place, we put the air pipes on. The air compresses down the diaphragm, presses down on the stem, presses down all the way through here, and then the splines will then open up the valve itself. Like so.